Hey everyone, welcome to Java for Beginners. In this course, you're going to learn everything you need to know about Java from the basics to more advanced concepts. So by the end of this course, you'll be able to write Java with confidence. If you're looking for a comprehensive, easy to follow, and well-organized course that takes you from zero to hero, you're in the right place. You don't need any prior knowledge of Java. You don't even need any knowledge of programming in general. Everything you need to know about Java is here in one place, so you don't need to jump back and forth between random tutorials. If you're new to the channel, be sure to subscribe because I plan to upload more content like this in the future. Let's get started by getting our environment set up. So we need to do a couple things before we run our first Java program. We first need to download Java. So I just went to Google, I put download Java, and we'll click on the Oracle link. And then if you go down here, we're going to download JDK 17 LTS. LTS stands for long-term support. So we'll go to JDK 17. We'll go to whatever system you're on. I'm on a Mac, and I'm going to do the x64 DMG installer. Now you might be saying, I thought we were downloading Java. What is this JDK? Well, that stands for Java Development Kit. Now, Java itself is just a language, but you need the JDK in order to run Java code. So I actually already have this downloaded, so I'm going to hit cancel, and I'm going to click on the version I've downloaded. So once that opens up, just double click on the package and just install like any other program. We'll hit continue, we'll hit install. Now you got to enter your password. All right, so that probably took like 10 seconds. We'll hit close. We'll move this installer to the trash. Now, if you want to ensure that this worked, what we need to do is we need to go to our terminal, open up a new terminal, and we'll type in Java C -- version. And we see that Java C 17.0.7 is successfully installed. Now, the second thing we need to do is download what's called an IDE, or an Integrated Development Environment. Now, there are a bunch of these that you can use. The popular ones include Eclipse, IntelliJ, NetBeans. I've always used IntelliJ and I've been really happy with it, so that's what we're going to use for this course. So we'll click on download. Again, whatever system you're on, Windows, Mac, or Linux. I'm on Mac. Select the correct chip and click download. The community edition is completely free. So this is a pretty big download. Again, I downloaded it previously, so I'm going to hit cancel. All right, so the first thing we need to do is drag this over into our applications folder. All right, so let's double click IntelliJ. Wait for it to verify. IntelliJ IDEA is an app downloaded from the internet. Are you sure you want to open it? We'll click open. All right, so the first thing that pops up is if you have a previous version of IntelliJ and want to import the projects, then you would click previous version. If this is a brand new fresh installation, then we'll click on do not import settings. All right, now if you want to change your theme here, you can do, light theme, high contrast, or Darkula. I always like to go with Darkula, so I'm going to leave it with that. Go to projects and click on new project. All right, so let's call our first project Hello World. We'll keep the location the same. We're not going to create a Git repository. We'll leave everything else the same. And then we'll click create. All right, so this is IntelliJ. This is our IDE. I'm going to make this full screen. I'm going to make the font a little bit bigger. All right, so I'm going to change the font to 18. Let's see, yeah, that's much better. Now, the first time you run it, if you look down here, there are going to be just a few things that it has to install and download in order to get everything up and running. All right, so I know the first time you look at an IDE, it can be a little bit overwhelming. There's a lot going on here, but we're only going to focus on a couple things for now. So on the left side here, this is our project structure. So our project is called Hello World, remember? We have this idea folder, don't worry about this. We have this source folder here, and then inside of here we have main. Now this is the file where we're going to be writing all our code. And if you see right here, it's called main.java. Every Java file has to end with .java. Here on the right side, this is our editor. This is where all our code goes. So I'm actually going to go ahead and delete a bunch of stuff here. So this text that you see in gray here with the 2 slashes, these are what are called comments. You can have as many or as little comments as you want. They don't affect the code at all. This is just to leave notes as a programmer. I'm going to go ahead and delete all of the comments. And I'm actually going to go ahead and delete all of this here. So we just have these 6 lines here. So don't worry about what this means right now. Let's go ahead and if we hit this green play button here, this is going to run our program. So once it builds, you see this window pop up here. This is called our console. So this kind of gives information about our program when it's running. It will, if we want to print anything out to the console, it'll show it here. So don't worry about what any of this means for now. The only thing I guess we could worry about here is, first of all, I'm going to change this to print ln, and I'm going to change what's in here to hello world. I'm going to run that. And we see that hello world gets printed to the console. So this line shows that we want to print something out to the console. You see we have these parentheses here, and then we have in quotations, hello world. So whatever is in here is going to be what gets sent to the console. All right, so now that we have everything up and running, everything's working and looking good, let's move on to the next video. All right, before we move on, I want to go over this first program and just make sure everything makes sense. I want to go line by line and give at least a high-level overview of what's going on. I feel like that'll help moving forward. And oh, by the way, if you're wondering why the user interface looks different, I was in the settings and I noticed that they had this new UI released in beta. So I enabled it and I don't know, I think it looks pretty cool, so I'm going to stick with it. So let's go ahead and delete everything and start from scratch. So the first thing that we need in a Java program is a class. So we'll type public class main. So the name of the class is called main. And in a Java project, you can have as many classes as you want, and the name of the class can be whatever you want. So it can be something like fish or taco. And wow, I realized that I must be really hungry. Let's say you're making a video game. And in the video game, you want a class for an enemy. You want to have a class for a weapon. You want to have a class for like your main character. Whatever it is that you need it to be. The only constraint is that the name of the class has to match the name of the file. So if we did something like Betsy, it's going to have this red squiggly line here. It's going to say class Betsy is public, should be declared in a file name betsy.java. So that's really the only constraint there. So let's do public class main. And then in here we have these what are called squiggly braces. I don't know, some people call them curly brackets. Let's just say curly braces. In here, this is where all the code for this class would go. So inside of these curly braces, this is what's called a code block. So our class first has the class header. It has the class body, which is inside of a code block. And the entire thing makes up a class. Again, you can have one or as many classes as you want inside of a Java program, but a Java program is made up of all classes. All right, inside of a class, we have what are called methods. Now, methods are units of work that need to be done, and you can have as many methods as you want inside of a class. So as we saw in the previous video, we had a method called main. So we had public, static, void, main. And then we had parentheses here, and we had string, brackets, args. And then we had the curly braces again. So there's a lot of stuff going on here. Don't worry too much about all these different keywords. We don't have time to go over it in this video, but each one of these keywords can have their own tutorial. And by the end of this course, you're going to understand what all this means. But for now, don't worry too much about it. Just know that the method name is called main. Inside of these parentheses, we have string args. This is what's called method parameters. Don't worry too much about it for now. But again, we have these curly braces. This is where the body of the method would go. So as we saw previously, we had one line which printed to the console. So just like with a class can have as many methods as you want, a method can have as many lines of code in here as you want. So let's go ahead and just type hello YouTube and hello Sam. And if we print that out, we see that we get 3 lines printed to the console. Now each one of these lines is called a statement, and we know it's a statement because there's a semicolon at the end. Now if we delete the semicolon, we try to run the program, we see that we get an error. It's saying Java semicolon expected. We also see here that we get a red curly line, and if we hover over it, it says semicolon expected. Now, this is one of the benefits of having an IDE, is that even before running your code, it can recognize that there's an error. And the IDE can also, as we see here, it highlights certain keywords. So there's a lot of benefits to having an IDE. All right, now you might be asking yourself, why are you adding this weird spacing to this program? Why don't we just write this all on one line? And yeah, technically, we could have our entire program on one line, but look at what happens when we do that. Let's put this all on one line, and imagine you give this to another programmer, or a programmer gives this program to you. It's really hard to tell where one thing starts and one thing ends. If we run it, everything still works. But generally, and yeah, pretty much always, this is bad practice to have it like this. So let's go ahead and revert that. And the more code you look at, you're going to just be able to pick up on things quickly, and you'll just know that code written like this is written correctly and it's more readable. And it's kind of hard to tell with this small program, but once you have, say, a bunch of methods, you're going to be able to easily just go to a method and be like, okay, what class does it belong to? Okay, let's go up, let's go back 1 tab. Oh, okay, this is part of the public class main. Now, the last thing I wanted to go over before we end this video are a couple of concepts. There's something called compiling your program and running your program. So when we hit this green play button, the first step is that it compiles your program. This takes this human readable code and it converts it to a bunch of zeros and ones that your computer can understand. This is the compilation stage. The next step is that it runs your code. So this is the computer actually executing your code. So when you hit this green play button, your program is compiling and running. If this doesn't totally make sense, that's fine. We're going to be going over classes and methods more in depth later on. So don't worry about it too much, and let's move on to the next video. All right, next up, we're going to talk about variables and data types. Now, variables are one of the most important parts of your program. They're one of the building blocks of every program. And luckily, they're a pretty simple and straightforward topic. So a variable is a piece of data that holds a value. So a piece of data could be something like, we have to give it a name. We'll say it's X. And that equals a value, say the value 10. Now, whenever we create a variable in Java, we need to give it a data type. So this can be something like an integer or a string. So we have to put the data type in front of the name. So it would be int for integer, X is the name of the variable, and it equals a value of 10. And since this is a statement, we need a semicolon after it. Now this is one way to create a variable. We could also what's called declare the variable in this line here, and then we can initialize the variable in the next line. And this is doing the exact same thing. So let's change this to age, and let's put this all on one line. So we have a variable age equals 10. Let's create another variable, and let's call it height, and we'll do the height in inches, and we'll do, I don't know how tall 10-year-olds are, 40 inches. All right, it's a very short 10-year-old. So once we have this, we can just print these out. So we'll do system.out.print. So remember before we had quotation marks and we wrote something here? Well, you can do the same thing with variables. So you could actually write like 10 in here or 40, or you can write the variable name. So let's go ahead and run that, and we'll see it prints out a 10, and the value of age is 10. So when we have this equal sign, this is called the assignment operator, and it goes from left to right. Normally in math, when you see equal, it means that two values are equal on the left and right. In programming, it's a little different. To represent equality, there's another way to do that, which we will go over in a future video. All right, so why are they called variables? Well, the definition of a variable is something that can change over time. Okay, I don't know if that's the official definition, but that's the idea. So when you have these variables, later on in your program, you could change their value. And the way you do that is you just assign it a new value. So we could do age, say this person had a birthday, and we'll go age 11. And when we change the value here, we don't need to put int again. If you put int, it's going to think you're trying to create a new variable, and you can't have two variables with the same name. So we'll do age equals 11, and let's print that out. So we see down here, initially we had 10, we updated the value of age, and we have 11. So integer is one data type. Another data type that we have is a double, and this represents decimals. So we'll do double, and we'll say double, let's say it's their weight. So we can do, their weight is 112.6. So in here, let's go ahead and change this to weight and print that out. And we see we get 112.6. Now, what if we go to age and we try to assign it a decimal value? Well, as you see here, it's going to complain and it's going to say require type int provided double. So you have to make sure that the value that's being assigned matches what the variable's data type is. Otherwise, it's going to complain. And you won't actually, if you try to run the program, it's going to throw an error. So we have ints, we have doubles. We also have what are called strings. And a string is just a bunch of text. We've seen this before. And of course, we have to give the string a name. So we'll put name in here. And we'll say name is Sam. And we'll print out that name. And we get Sam. So we have ints, doubles, strings. Another type is a char. So this just represents a single character. And notice that when we have a char, we have to put this in single quotes. So we'll change this to A. So when we add in when we try to print out a C, it prints out an A because it's the value. And then the final data type that I wanted to go over is Booleans. And a Boolean has one of two values. It's either a true or a false. So either, and of course we have to give it a name. We'll just say, what do we want to do here? So for this person, we'll have, is male, and we'll put true. So you could either have true here, or you could have false. So if we print that out, it will print true. Now, why would you want to have something like a Boolean? Well, later on when we do something like if statements, where if we want to check if something is true or false, this will come in handy, but we'll get to that in a future video. The final concept that I wanted to go over is a literal. So when we have something like this, where it's an actual, like a string format, this is what's called a string literal. So it's something that's not tied to an actual variable. So you could also have this with numbers. So say we have this right here. This is another literal. In this section, we're going to cover arithmetic operators. So in Java, you can add things, you can subtract, you can multiply, you can divide, and there are a couple other operators that we're going to cover in this section. So let's create a couple of variables. So we'll do int result1, int result 2. And a little trick here is we don't actually need to do this on two separate lines. You can make these comma separated, and that way you can write, or you can declare two variables in the same line. So we'll do result1 equals 10 plus 7, and we'll do result2 equals, actually, you know what, let's just do result1 for now. So let's print that out. Result1, run that, and as expected, we get 17. All right, let's go ahead and subtract. 10 minus 7 is 3. And let's go ahead and multiply. And we get 70. I'm going to hold off on division for now, just because division with integers can get a little weird. But another thing we can do is let's initialize result 1 to 10. Let's initialize result 2 to 3. So another thing that we can do here is we can create another variable called result 3 and set that equal to result 1 plus result 2. And then let's print out result 3. And as we see, we get 13 because we're taking result 1, which is 10. We're adding it to result 2, which is 3. So that's 13. And then it assigns it to result 3. So when we print out result 3, the answer is 13. Another thing that we can do here is we can say result 2 equals result 2 plus, let's just say 6. So what that's doing here is it's taking result 2, even though we're assigning it to result 2, that's totally fine. We take result 2, which is 3, and then we add it to 6, so that becomes 9. It takes 9 and it assigns it to result 2. So result 2 is now 9. All right, let's do some division. So let's do result 1 equals 10 divided by 2. So last time I checked, 10 divided by 2 is 5, and we get a 5. But let's do 10 divided by 4. All right, 10 divided by 4 is 2.5. But wait, this is saying it's 2. Is this wrong, or what's going on here? Well, what's going on here is that it's taking 10 and it's dividing by 4, which is 2.5. But since we're dealing with integers, we can't have decimal values. So what it does is it truncates that value and just prints out the integer part. So this is something that you have to be wary of when you're doing integer division. Now, if we change this to a double, and actually when we print this out, it's still 2 because these are both, we're still doing integer division here. So what we have to do is we have to do this, we have to change this to 10.0, 4.0. So now these are both doubles, and then it'll print out 2.5. What we can't do is change this back to an int, because it'll complain that we're required an integer, but we're providing a double for the value. So this is going to throw an error. So the result of the right side has to match the type of the left side. Now let's go back to where we had result 1. Result 1 equals result 1 plus 7. And it's complaining because we first need to give result 1 a value. So let's set result 1 equal to 3. So we're doing result 1 equals result 1 plus 7. If we print that out, we get a 10. Now there's a shorthand way of writing this, and that is to write result 1 plus equals 7. And this is the exact same thing as what we previously had. It's just the shorthand way of writing it. And we could also do this with subtraction. We could do it with multiplication or any arithmetic operator. So we're taking result 1, which is 3, we're subtracting 7, and we're setting that to the value of result 1. All right, the next thing that I want to talk about is the modulus operator. So what the modulus does is it divides and it takes the remainder. So let's set result 1 equal to 10. Let's just take result 1 and we'll set it equal to 10 modulo. So this operator is called the modulus operator. When you take the modulus of a number, it's called the modulo. So 10 modulo 4, if we print that out, 10 divided by 4 gives us a remainder of 2. If we do 10 divided by 5, since 5 equally goes into 10, we don't have any remainder. So you might be asking yourself, why would I ever need something like this? Why do I care what the remainder of a number is? Well, one example is if you're trying to figure out if a number is odd or even. So if we do 10 modulo 2, if there's no remainder, we know that result 1 is an even number. If we change this to an 11, the remainder is going to be a 1, and then we know that it's an odd number. Next thing we're going to cover are the increment and decrement operators. So if you ever want to add 1 to a variable or subtract 1, what we can do is we can do, as we've seen, result 1 equals result plus 1. We need to give result 1 a value. So let's say it's 11, and then we set result 1 equal to result 1 plus 1. So when we print it out, it's 12. But a shorthand way to do this is to simply type result plus plus. And this does the exact same thing, prints out a 12. And we could also do it with subtraction. So result minus minus subtracts 1, and we get a 10. So those are the decrement and increment operators. So if you've ever seen the language C++, basically what that's saying is it's taking the language C and it's kind of incrementing it by a version. So just a little fun fact there if you didn't know. All right, operator precedence. So just like math, if you have something like 1 plus 1 divided by 2, even though the addition happens first, or it happens first from left to right, it actually does the division first because the division has precedence over addition. And this works the same way with programming. So if we have result 1 equals 10 plus 2 divided by 6, it's not going to take 12 and then divide it by 6 and give us a result of 2. You see, if we run it, we get a 10 because what it's doing here is it's actually taking 2, dividing it by 6, which we know in integer division, it would actually be 0. So let's actually change this up. So let's do 6 divided by 2. So instead of getting 16 divided by 2, which is 8, we're taking 6, we're dividing it by 2, which is 3, and then we're adding 10 to it. Now, one way to get around this is, just like math, we can use parentheses. So if we put parentheses around 10 plus 6, it's going to do that first. It's going to have 16, divide that by 2, and print out an 8. And in this print statement, we can actually, if we want to make this a little bit nicer, you can actually mix strings with integers or doubles. And we could just say the result is, and then if we add a plus here, this will concatenate everything together. If we run that, and it'll print out the result is 8. So I just wanted to mention that just in case we do this in the future, this all makes sense. And we could even do something like result 1 plus result 1, and it's going to print out a 16. So you could actually do math operations within this print statement. In this section, we're going to look at how to get input from the user via the console. This is going to allow us to make our programs a lot more interactive. Now, in Java, there are several ways to do this. So I'm going to teach you guys the way that I was taught and what I think is kind of the simplest and most straightforward way to do this. Now, we're going to need to write a few lines of code here. So what we need to do is we need to create a scanner. A scanner is an object. I know we haven't talked about object, but it's an object that allows us to get input from the user. So just like we had like int x, or we had double y, we had a variable that was called x, and it was a type int, or a type double, which was a variable called y. This is a type scanner, and we'll call it in. So we also need to set scanner in equal to new scanner. And in the parentheses, we type system.in. Don't worry too much about what this means. Once we get into objects and classes, this line is going to make a lot more sense. But just know that we need this line to create our scanner. Now, we see that this is in red, saying cannot resolve symbol scanner. And that's because we need to what's called import it into our program. So something like int or double. So these are what are called primitives. We don't need to import anything. Java just knows what an int and a double is. However, something like a scanner, we need to import it into our project. So if you're using IntelliJ, if you hover over it, you can just click import class and it adds it to the top. Otherwise, you can just manually type this in. So this is saying, hey, I want to use a scanner. So now we let the program know and it recognizes what a scanner is. So this is just declaring and initializing our scanner. Now in order to use it, we would just type in dot next line. So if we run this, this will, you can't really tell, but the program is now halted and it's waiting for the user to enter some kind of input here. And then once you enter that, then the program ends. So in order to actually save this value and start using it, we need to save it to a variable. So if we create a string and we'll call it user input, and we'll set it equal to whatever gets saved in n.nextLine, and then let's just print that out. So if we print that out, now if we run this, again, it halts, waits for us to enter something in, and then it prints that out to the console. Now, one thing you might not have noticed is previously we had been using println to print stuff out to the console. What this does is after it prints it out, it prints a blank line out. So you see there's a blank line here. If we just want to use print, then it omits that extra line. So depending on what you need to do, you can either use print or println. So if we want to improve this a little bit, first let's go ahead and delete this int and this double. When the program is running, you can't really tell that it's running, right? So let's prompt the user for some input. So after we create our scanner, let's just say system.out.print, and we'll ask the user, what is your name? And then once we get that user input, let's just say hello plus the user input. So if we run this, it says, what is your name? Sam. Once we hit enter, it prints out hello Sam, and the program ends. So if we want to just do a quick run through here, we see that we first create the scanner object. This allows us to get input from the user. We print out what is your name. Then what we do is we use this in.nextLine to halt the program while it waits for the user to enter something. Once the user presses enter, it saves that input to this variable called user input. And then finally we print out hello plus whatever the user entered. Before we move on, I did want to talk a little bit more about comments in this section. So if we wanted to comment something, we would have these two forward slashes, and then anything after it on this line is a comment. And this is totally optional. It doesn't affect the program whatsoever. This is just for yourself or for other programmers looking at this code. So we could do something like create scanner and ask user for input. And then down here we can type print user's name. So currently our program is very, for lack of a better word, dumb. It sees a statement, it executes it, it goes to the next statement, it executes it, and so on until it gets to the end of the program. But sometimes in our program, we want certain pieces of code to run based on certain conditions. This is where the if statement comes into play. So let's get rid of all of this. Let's get rid of this statement up here. And how it looks like is we just type if, and then in parentheses, right here, this is the condition that we want to evaluate. And if that condition is true, then we create a code block, and whatever code is in here will run. If the statement or if the condition here is false, then it just skips over the code block here and goes to the next line of code. So let's write some print statements here just so we have a better idea of what's going on. So in here we'll say in if statement block. And then down here we'll say, let me copy this, and we'll say after if statement. And then in here, we need a condition. So this needs to evaluate to either true or false. So what we can do here for now is to just have a Boolean value. Remember, this is This is something that has either a true or a false value. And let's give it a name. And what should we call this? Sometimes in programming, the hardest part is figuring out what to name your variables. So we'll just call it is true for now, and we'll give it a value of true. And then in this condition here, we'll type is true. So if we run that, and since we didn't have a println after, it prints everything on the same line. So let's add println and add println. All right, so down here, we see that it prints out in if statement block, and then it prints out after if statement. So it goes in the if statement, it sees that is true, is in fact true. It prints this statement out, and then it exits the if statement and then prints out after if statement. Now let's set this value to false. And you know what we can do is we could change this to false, or we could literally put false in here. And if we run that, we see that this evaluates to false. It doesn't print out in if statement. So it skips over the if statement, and then it will print after if statement. All right, we also have the concept of an else. So an else is code that will run only if the if statement is false. So how that looks like is we would type else, and then in curly braces, we have another code block in here. So let's print something out. Let's say in else statement block. And we'll change this back to is true. And we'll run it, and we see that. So since the condition inside of the if statement evaluated to true, it prints out this line here, and then it skips over the else statement and then prints out after if statement. So let's change the variable names here. We'll say go in if statement, and then we'll create another variable called go to else statement, and we'll set this equal to false. So in this variable, we'll say go to else statement. If we run that, we see that we get in else statement block after if statement. So what's happening here is we have the if statement. Inside of here, this evaluates to false because the value of go to else statement is false. So it doesn't go inside of the if block. Instead, it goes directly to the else block. It prints out in else statement block, and then it prints out after if statement. So that's the basic idea of an if-else statement. We're going to look at what are called relational and logical operators next, and this allows us to do more with if-else statements. All right, currently in our if statement, the condition is very simple, right? We have just a Boolean variable that evaluates to true or false. But usually we want to do something more complex than this. This is when relational operators come into play. Relational operators allow us to compare two elements. We can compare them for equality. We can compare to see if one is greater than the other, one is less than the other. So there are 6 relational operators within Java, and we're going to go over all of them. So first we need to create 2 variables. Let's just create, do we want to just do x and y and keep it simple? Just because we're new to this, let's just keep it simple. We'll do int x equals 5 and int y equals 8. So let's go into our if statement if the 2 values are equal. So we'll say if x equals y. So now you might be saying, why am I using 2 equal signs here? Well, we already learned that the equal sign, a single equal sign, is the assignment operator. This assigns a value to a variable. So we can't, if we did an equal sign here, this would it would be ambiguous, and the Java would think you're trying to assign values together. So we have to use 2 equal signs. Obviously, we know that 5 and 8 are not equal. So when we run this, it goes into the else statement. Now there's also the not operator. So if we want to go into our if statement, if these aren't equal, well, then we would do an exclamation point and an equal sign. And since x does not equal y, this whole expression evaluates to true, and then it goes inside of our if statement. And if we run that, we see that we're in the if statement block, and then after if statement. So those are the first two relational operators. We also have greater than. So if x is greater than y, sorry, this is less than. If x is less than y, if we run that, we see that x is in fact less than y, and it goes inside of the if statement. We can also do if x is greater than y, which we know is not true. Then we go into the else statement. And then the last two are greater or equal to, and also less than or equal to. So let's say we have, let's create another variable, we'll call it z, we'll set it equal to 5. So we'll say if x is less than or greater than z, since they're equal, it goes inside of the if statement. All right, so we covered relational operators. Let's talk about logical operators. So in our previous program, we compared two values. If x is less than or equal to y, then go into the if statement. But sometimes we want to do more than one comparison. We would want to do, say, if x is less than or equal to y, and so. If both of these are true, then go in the if statement. So what we would do is, we wouldn't type and, but we type double ampersand. And then we would write our next expression. So we can do something like, if x is less than or equal to z. So if x is less than or equal to y, and x is less than or equal to z, then go in the if statement, and we see that it prints out in if statement block. Now the important thing to remember is that both of these have to be true in order to go in the if statement. So if x is, let's say, equal to y, which we know is not, right? X is 5 and y is 8. So even though this side of the expression is still true, since this part is false, the entire expression evaluates to false, and it goes into not the if statement, but the else statement. So that's the logical operator and. We also have ors. So if this is true or this is true, go in the if statement. So if one of them is true, then the whole thing evaluates to true. And as we see here, it goes into the if statement. With ors, only one part has to be true. With ands, both sides have to be true. And we can have as many logical operators within an if statement condition as we want. So we could do if x equals y or x equals z, and it could be really whatever we want, right? If x does not equal z. So what do we think is going to happen here? So, well, this is actually where operator precedence comes into play. So with logical operators, the and will always evaluate before the or. So what's actually happening here is it's evaluating this expression here first. So whether this is true or false, this whole side becomes true or false. So is x less than or equal to z? Yes, it is. It's equal. And is x not equal to z? Well, this is actually a false. So this whole thing would technically evaluate to false. And then it compares these two values. Is x equal to y? This is a false. And then we also have false. So if we want to run this, we see that this goes inside of the else statement. Now, this can be a little bit confusing. The good practice here is when you have a kind of complicated expression like this, parentheses are your friend. A better way to write this would be to have parentheses around the and. Now, it doesn't change the program or anything. This is really just to improve readability, because as we see, if we run it, we still get a false. It goes into the else statement. Now, the last logical operator that I wanted to go over is the not operator. And I think in the last video, I called this the not operator. This is actually the not equal operator. The not operator is an exclamation point, and what it does is if there's a true expression, it changes it to false. If there's a false expression, it changes it to true. So let's just say we have if x equals y. Let's do if x equals z, which we know is true, right? X and z are both 5. So it goes into the if statement. But what we can do here is we can put a parentheses around this, and we can add an exclamation point. And what it does is it takes whatever this expression is, which is true, and it just flips it. So in this case, this whole thing would be false. And if we run it, we see that it goes inside the else statement. This is a pretty, I don't want to say useless example, but this is like, it doesn't really have any context. We're just using variables here with numbers. Once we get into kind of more practical examples, the uses of these operators will make more sense. In this section, we're going to look at nested if statements. So this is having an if statement within an if statement. So previously we had if, and then we had some kind of condition that evaluates to true or false. And if that was true, then it would go into the code right here. Otherwise, if that's false, it would go into the else statement, and then we would have our code here. What we can also do is inside of this if statement, or this if statement code block, we could have another if statement, another if else statement as well. And we could also have this within the outer else statement. We could also have another if else. So, and we can really have as many of these as we want. And one thing, I'm not sure if I mentioned it before, but we technically don't need to have an else statement with an if statement. We can have an if statement by itself. However, we can't just have an else statement by itself. So I think the best way to understand this is if we made a program, or we did a little like mini project here where we made a guessing game where a user guesses a number between 1 and 10, and then we let them know whether they're correct or whether the number is higher than their guess or lower than their guess. So let's go ahead and let's delete everything here. In order to receive data from a user, we've done this in the previous video, we've used a scanner. So we did scanner in equals new scanner. And then in this parentheses, we type system.in. So let's first prompt the user to guess a number. We'll say, guess a number between 1 and if I can spell that correctly, there we go. Guess a number between 1 and 10. So the next line is we go in.nextLine. Remember, we did this in a previous video. In.guessLine prompts the user, it halts the program and prompts the user for input. And we want to save that value in a string. We'll call it input. So let's first give ourselves a number that, or a target that we want the user to guess. So we'll just say answer and we'll set it equal to 3. So once the user guesses a number, we'll check if they got it correct or not. Now this is something here that I have to introduce that it's a little new. So with this in.nextLine, it treats this as a string, but what we want to compare it to is, but what we need is an integer if we want to compare it to the answer. So like for example, let's just print out what the user guesses. So if we run this, and the user guess a number between 1 and 10, and we type in 5, and then we print out a 5. Now technically in Java, this is still, even though it's a number and we know it's a number, it treats it as a string. So whether you type in 5 or you type in any type of text, Java still will always treat this as a string, but we need it as an int. So what we can do is we can convert it by, let's create another variable here and we'll call it user guess. And we'll set that equal to not input, but what we can do is we can type in integer.parseInt, and then within the parentheses, we put input. So this basically takes the input as a string, converts it to an integer, and saves it into this variable. So now if we want to print out user guess a number between 1 and 10, it still looks like a 5 to us, but within Java, it's now an integer. So hopefully that makes sense. All right, so now that we have the user's guess and we have our answer, let's compare them and see if they're equal. So we'll do if user guess equals answer, then we'll just type we'll say, you got it. Good guess. Otherwise, If that's not true, it'll go into this else statement. So at this point, we know that the user guessed something and it's not our answer. So we can now check if what they guessed is either greater than or less than our answer. So let's just print out system.out.print and say, sorry, your guess was, and then in here, we're going to have our nested if-else statement. So if the user guess is greater than our answer, then let's print too high. Else, and I'm going to copy this, and I'm going to say too low. So let's go ahead and run this program, and then we're going to walk through it and just make sure we understand everything. So guess a number between 1 and 10. So we'll guess 5. And then it'll say, sorry, your guess was too high. And we have an extra space in here, so I'm going to go here, and I'm going to delete the space here. All right, let's try it again. And we'll say, guess a number between 1 and 10. We'll guess 2. Sorry, your guess was too low. Run it one more time, and we'll enter a 3. And it'll say, you got it, good guess. All right, so let's do a walkthrough here. We have our answer, which is a 3. We create our scanner. We prompt the user to guess a number between 1 and 10. We get that input as a string. We convert the string to an integer and save it in a variable called userGuess. We then have our outer if statement, and we'll say if userGuess equals answer. So if this equals 3, then print out, you got it, good guess. If it's not, then we know that the user's guess is either greater than or less than the answer. So we'll say, sorry, your guess was, and then we have our nested if-else statement. So if the user's guess was greater than answer, then we'll print too high. Otherwise, we print too low. And the program ends. All right, hopefully that made sense. That is, I mean, if you look at it, guys, this is a pretty big program. Like for only being, I don't know how many lessons we're in so far. You guys know a fair amount of Java. You aren't a complete novice anymore. You can now say, hey, yeah, I know a little bit of Java. We still have other things to go through like loops and classes and methods, but I think we're making good progress so far. So just keep up the pace. In this section, we're going to go over the if-else ladder. Now, previously we saw that if we want to delete some of this here, we had an if statement, we had a condition in here, and if that condition was true, we would execute the code that's in the code block. And if we have an else statement, then if this part is false, if the condition is false, it would run the code that's in the else statement. But sometimes we might want to have more than one case. We might want to have 2, 3, 4, 50 cases. Well, Java allows us to do this with the if-else chain. And basically how that looks like is we would have our normal if statement here, and then we would write else if, and then in parentheses we would put, this would be condition 1 in here. In the else if, we would have condition 2. And if condition 2 is true, then we would run the code in here. We could also have another if else with condition 3. If that's true, run the code in here, and so on. And then finally, we can have an optional else statement with no condition. And if it doesn't go into any of these code blocks, then it would just run whatever's in the else block. So let's do an example program here. So let's keep the scanner here, and let's have the user give us their age. And based on their age, we'll print out what they can do. So when we prompt the user, we'll just say, how old are you? And everything else is going to be the same here. We have our scanner. We get the input from the user. We save it in this string. Since it is in string format and we need an integer, we convert it to an integer and we save it to, let's just say, age. So let's start with, if your age is greater than or equal to 35, here in the United States, once you're 35, you can run for president. So we'll say, you can run for prez. Else, if your age is greater than or equal to 21, here, if you're 21, then you can start drinking. So we'll say, congrats, you can buy a drink. And then let's have one more, and we'll say, if the age is greater than or equal to 18, then we'll say, you can vote. And then if they're not over 18, let's have a catch-all and say, sorry, you can't do anything. And let's do a sad face. All right, so let's go ahead and run this. We'll say, how old are you? Let's start with 40. And it says, you can run for prez. All right. Now let's do, how old are you? Let's do 21. And it goes into here, it says, congrats, you can buy a drink. Let's test the other case. Let's do, if you're 20, and it says you can vote. And then finally, let's test that catch-all case. And let's say, how old are you? We'll say we are 17. And it says, sorry, you can't do anything. Now, the last thing I wanted to point out is only the first matching case will run. So that's why when we put something like, if you're 40, it goes here and it says, yeah, okay, my age is greater than 35. Let me run the code in here. And then it exits this entire if-else ladder. So let's say we flipped this and the first case was 18, then 21, then 35. Even if we put 40, it won't go into this block right here, which says, well, it says you can vote, but it would be you can run for president. It would first go here and says, yes, 18 or 40 is greater than 18. So it would go into here and it wouldn't run into any of the cases. So that's just something to keep in mind when you're doing multiple cases. Make sure that it's in the order that you want or that makes sense for the code. In this section, we're going to cover this switch statement. Now, the switch statement is very similar to else ifs, but there are a few subtle differences which we're going to cover. So how it works is you first write the keyword switch, and then in parentheses, you have some sort of expression. And then you'll have your curly braces, and then you'll have a set of one or more cases that can match this expression. And if it matches that expression, it will run the code within that code block. So let's say we're teaching a class and we're giving a student a grade. And then based on that grade, we'll give them a certain amount of points. So let's create a variable here called points, and we'll set it to 0. And then let's give this person a grade of, it can be like A, B, C, D. Let's give them a B. And you know what? Since we're just doing one character, why don't we just use the char type and we'll put this in single quotes and we'll give them a B. Then within our switch statement, we'll have the expression here, and the expression is going to be the grade. So then our first case here will be if the person got an A. So you write the keyword case, you write what you're matching against, and then you type a colon. And then under here, we'll just, why don't we add 100 points to their total point amount. And then once we're done with a certain case, we type break. We'll talk about this more in a second. So let's do another case for a B. We'll give them 90 points for it, and we'll break out of it. And let's just do one more for a C. For case C, go ahead and add 80 points. And then just like when we had a catch-all case with our else ifs, we had that final else, remember? Here, what you would type is default, and then this is basically a catch-all. So if it doesn't go into any of the cases, it'll check the default, and why don't we just give them 70 points. All right, so after the switch statement, let's just go ahead and print out how many points they have. So we'll say you have and then we'll print out the amount of points, and then we'll type points. So they have a B, so it's going to go into this case here. It's going to add 90. It's going to break out of the switch statement, and it's going to go to this print statement. Let's go ahead and run it. And we see you have 90 points. And if you notice here, I actually realized that I forgot the break here. So that's fine. It shouldn't change the result. You have 90 points. So a couple things here. First of all, the default statement is optional. So if you don't have this and you run it, everything will still run totally fine. Generally, it's good practice to have a default, just kind of as like a safety net. So I'm going to go ahead and leave that in there. Second thing is these breaks are also optional, but your program will behave differently if you leave it out. So let's go ahead and take out all the breaks and let's see what happens. So you might be thinking, okay, it's going to go in here. It sees that it has the grade of B, and then it's going to go into this case here, 90, and then it's going to just print out 90. Well, let's go ahead and run and see what happens. Well, it says you have 240 points. So obviously this is a bug. So why is it doing this? Well, when you don't have a break, it will actually, it'll still go into this case right here, case B. It'll add 90 points. But since there's no break, it goes into every single case afterwards until it reaches a break. So it'll go add 90 to points. It'll add 80, which will be 170. And then it'll add 70, which is 240, which is what we got, right? So let's see what happens if we add a break right here. If we run it, it says you have 170 points because it'll go into case B, it'll add 90, then it'll go to case C, it'll add 80, which is 170, and then it'll break, and then it goes to this print statement. And this will work even if the points are blank. So if I actually make this blank, let's go ahead and change this to A. And if we run it, we see that it has 80 points because it goes into case A, right? But since there's no break, it goes to case B. There's no break, goes to case C, adds 80, then breaks out, then goes to the print statement. So just a couple things to keep in mind when using a switch statement. In this video, we're covering the ternary operator, which is essentially a condensed version of an if-else statement. So say we have a string called message. We have an int num, we'll set it equal to 7. And we can say if num is greater than 10, then we'll set message equal to num is greater than 10. Else, num is not greater than 10. All right, let's print out message. And as expected, we get num is not greater than 10. So if we want to write this using the ternary operator, let's comment this out. And we'll set message equal to, so we'd say, is num less than 10, question mark. So right here, this is our condition. And if this is true, then set message equal to num is greater than 10. Else, which is just a colon, num is not greater than 10. And if we run that, we get the same exact result. So here it's saying we're going to set message equal to, what are we setting it equal to? Well, is num less than 10? If it is, then set it equal to num is greater than 10. Else, num is not greater than 10. So as you can see here, we can write this all in one line. It takes up less space. You may also see people space it out like this, so it's easier to read. All right, now we're going to use what we've learned in previous sections to do a little project here. We're going to build a calculator. Now it's going to prompt the user to give us two values and then tell us whether they want to add, subtract, multiply, or divide. Now, I recommend you pause the video and try it out for yourself and see how far you can get. All right, the first thing we need to do is create a scanner and get data from the user. So I'm going to create a scanner. We're going to call it scanner. So we have scanner equals new scanner and system.in within the parentheses. We've done this in the previous videos. All right, so let's prompt the user for the first value. So we'll save the value into a double. We'll call it first val, and it's going to be scanner.next line. Now remember, scanner.nextLine gets the value as a string. So we need to convert it to a double. So it's going to be very similar to when we did, integer.parseInt, except this time it's going to be double.parseDouble. And we need to surround this scanner.nextLine in parentheses. So we need to do the same thing with the second value. I'm just going to copy, going to paste, and we're going to change the name here to second val. Everything else should be the same. And then finally, we need to see what operation they want to do. So we'll just do enter an operation plus, minus, multiply, or divide. We'll save it in a string called operation. So we'll just do scanner.nextLine. And since we're saving this into a string, we don't need to do any type of conversion. All right, so we have everything we need from the user. Now we can just go ahead and check what the operation is. So we'll just say if operation. So here's the thing. Normally, right, when we want to do an if statement and we want to check for equality, we would just do equals, equals, and then the value. So in Java, strings are a little weird in that we can't just do something like equals plus. And we even get a warning that says string values are compared using the equal sign and not equals. It's saying like, this is not good that we're doing it like this. So once we get into objects, we'll understand why we can't use this for strings. But for now, we're going to go ahead and take their advice, and we're going to do it by going operation.equals, and then in parentheses, we'll do this plus sign. All right, so if we get a plus sign, we're just going to do system.out.print. And before we do this, I'm going to write out to the console and say the answer is, and then here we'll do first val plus second val. All right, so now we're going to do an else if, and now we could have actually done this with a switch statement. And that's the cool thing. We're at the point where we know multiple ways to do the same thing. So I could have done this with a switch. I just chose to do it with an if, there's really no reason. I just chose this to do it with an if just because, honestly, I didn't have a real reason to do it, but I could have done it with a switch. I think I'm just used to using else ifs. So we'll do else if operation.equals minus sign, and then we're going to do the exact same thing, except instead of adding, we're going to subtract, and I'm going to do the same thing with multiplication and division. So here we'll do multiply, multiply, divide, and divide. All right, and I think everything looks good here. Let's go ahead and test this out. All right, so we get enter a value. We'll do 12.25. Enter a value, we'll go 4.5. Enter an operation, we'll go ahead and add. And we get 16.75. All right, looks good so far. Let's do something like 3 and a 4 and a multiply, and we get a 12. All right, and then I don't think we need to go through subtraction and division. I think at this point we see that the program works pretty well. Now, of course, there are certain things that could easily break our program, like instead of putting a value in, someone could just put gibberish in, and we get this error right here thrown. So in the future, we'll learn how to handle something like this. But for now, I think this is pretty good. Now, we're not going to be able to sell this program to Microsoft or anything like that. but you know, it's a good starting point and a good foundation to build upon. Welcome back, everybody. In this video, we're going to learn about a certain type of loop, which is called the for loop. Now, a loop is one of the most powerful things you're going to learn in any programming language. So let's start with the basics. So far we've been able to write a statement. Then we go to the next line, we write another statement. We go to the next line, we write another statement. So basically it goes from top to bottom. Well, sometimes in programming you want code to run multiple times. So basically the code would run and then it would start back at the top, it would run again, and so on and so forth. So this is really what we get from using a loop. So what this looks like is we write for, then we write parentheses, open and close parentheses, and then we have a open and close squiggly brace. Very similar to an if statement, right? This right here between the curly braces is our loop body. Let's just go ahead and print something out. We'll say inside the loop. All right, so in the parentheses here, this is where the magic happens. We have three parts. The first part is called the initialization. So this is going to be a variable. So we'll create a variable called int I and we'll set it equal to 0. And this will make more sense in a second. So that's the first part. So then we have a semicolon and we go to the second part. This is the condition. This determines whether or not we go inside the body of the for loop. It's exactly the same thing as an if statement. It's a condition that evaluates to true or false. If it's true, it goes into the body. So our evaluation will be if I is less than 4. Then we have another semicolon, and the final part is the iteration. This runs at the end of every iteration of the loop. So what do we want to do here? We'll just add 1 to I. Otherwise, if we don't add anything, this loop is just going to continue to run forever. So we'll do I++, we'll run it, and we get inside the loop, inside the loop, inside the loop, inside the loop. That could be a song, inside the loop, inside the loop. Okay, anyways, let's go ahead and print out I here, just so we can see how the variable is changing through each iteration. Basically, when I say iteration, that means that's one time it runs through the loop. That's one iteration. So when we run this, we see we get 4 iterations. Basically, what's happening here is it creates the variable I, it sets it to 0, it checks, is I or is 0 less than 4? Well, yes, it is. Let's print out 0 right here. Then at the end of the loop, at the end of the iteration, it adds 1 to I. Then it checks, is 1, because I is 1 now, less than 4? Yes, it is. Print out 1. All right, let's add 1 to I. Is 2 less than 4? Yes, it is. Print out the 2. Add 1 to I. I is now 3. Is 3 less than 4? Yes, it is. Print out I, which is 3. All right. Add 1 to I. I is now 4. Is 4 less than 4? No, it's not. Don't go into the body of the for loop. It reaches the end of the for loop. Then it just continues to the end of the program, which in this case, the program ends. So that's the idea of a for loop. Obviously, this is pretty much as basic as it gets. Just a couple things to go over here. The first thing is we don't have to initialize the variable in here. We could technically done I here and then just set I equal to 0 here. Another thing is, let's change this to like a 40. And then in here, we don't have to add it by 1. We can really do whatever we want here. We could do plus equals 2. Say we want to add 2 at the end of every iteration. So if we run that, we see we get 0, 2, 4, 6, 8. So it increments by 2 on every iteration. Another thing, we can technically leave this part blank here and then just have the I plus equals 2 at the end here. And this would do the exact same thing. Right, 0, 2, 4, 6, all the way down to 38. We can have it so let me change this back to I++. Let's change this to a 10, and let's say we start I at 20. Well, if we run this, the loop never executes because the control variable, which is I, is greater than 10 to start with. So this condition is false from the very beginning, and then not even one iteration of the loop will occur. Now, say we had something like I equals 0, run it while I is less than 10, and then instead of incrementing by 1, we decrement I by 1. Well, what happens here is once we run it, we see that I'm actually going to stop it because it's going to crash my system. We see that we had an infinite loop there. It got all the way down to negative 900,000. So this is something that as a programmer you have to account for. With the IDE here, it is smart enough to realize that loop executes 0 or billions of times, but sometimes it won't be able to recognize that. And you might run into an infinite loop. So again, that's just something that you have to be aware of. All right, that's a basic overview of for loops. This is a very simple example, but once we get into more complex topics, we're going to be using this more and we're going to get a lot more comfortable with it. All right, in this section, we're going to cover the while loop. This is another form of looping in Java, and it's very similar to a for loop. So what it looks like is you're going to type in the keyword while. You're going to have your open and close parentheses, and then in here, it's going to be your condition. And then you have your loop body here between the two curly braces. So once we reach this loop, it checks the condition. If the condition is true, then it goes into the loop body. Once it reaches the end of the loop, it goes back up to the top. It checks the condition again. If it's true, it goes back in the body of the loop. If it's false, then it breaks out of the loop. So let's create a variable here. We'll call it count, and we'll set it equal to 0. And we'll say while count is less than 10, then we'll just print out the value of count. So we'll do count. We're going to print this all on one line. And then I'm going to add a space here at the end. So I almost ran it without updating the value of count, which would have given us an infinite loop. Let's actually run it and see. So as we see here, it prints out a bunch of zeros. And that's because we never updated the value of count. So at the end here, let's do count plus plus. Let's go ahead and run that. And we see we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's happening here is we set the value of count to 0. We get to our while loop. We check, is count less than 10? So is 0 less than 10? Yes, it is. Okay, go ahead and enter the loop. Let's go ahead and print out the value of count with a space after it. So we get 0. Then let's update the value of count. Then we reach the end of the loop. So let's go back up to the top. Is 1 less than 10? Yes, it is. Print out the 1. Increment count, and do that all the way up till we get to 10. Then 10 is not less than 10, so it doesn't go into the loop. Then the program ends. All right, let's do something a little bit more interesting here. Let's create a compound interest calculator. So basically how that works is we have a starting value. Let's say we have $100, and on every loop, or let's say every year, our value goes up 10%. So after the first year, it'll go to 110. After the second year, it'll go 10% is 11, so it would go to 121, and so on and so forth. So let's give ourselves an initial value. So let's say amount, and let's start with, let's say 100. And I'm going to actually change this to a double because we are going to get decimal values. So we have $100. And then we'll also have a year here. So we'll say we start with year 1. And then we'll say while year is less than or equal to 10, then we want to update. We're going to update amount equal to amount times 1.1. And then let's go ahead and print out amount. So we have amount, and then, so we don't run into an infinite loop, we want to increment the year by 1 on every loop iteration. All right, so let's go ahead and run that. And we see we get, the first year was 110, right? The second year was 121, and then 133, and then it goes all the way up to year 10, which is 259. Now, I don't really like the way this is written with all the values after the decimal point. So why don't we format this so it only goes to the second value? So the way to do this is, for this amount value, we would wrap it in string.format. Now don't worry too much about the syntax here. Once we get into methods, this will all make a lot more sense. But we're going to do string.format, and then in quotations, we're going to do %2f, and then we need a comma here. So if we run that, So if we run that, I actually forgot a decimal place right there. If we run that, we see that we get 2 decimal places. So first it's 110, 121, 133.10, and so on. And if we want to make this look even better, let's add a $sign here. All right, so much better. All right, so that's the while loop. In the next section, we're going to look at one more type of looping in Java. The last of Java's loops is the do while. Unlike the for loop and the while loop, in which the condition is tested at the top of the loop, the do while loop checks its condition at the bottom of the loop. That means that a do while loop will always execute at least once. So what does this look like? So we write the keyword do, and then in here we have our loop. And then at the end, we type while, and then in parentheses, this is our condition. And then of course we need a semicolon at the end. So basically this is saying do whatever is in here while this condition is true. So why don't we create a menu system for a game? And then we'll basically just continue to display the menu until the user types in a particular value. So we need to create our scanner object here. We'll call it scanner. Let's create a variable here called user value. All right, and then in our loop body, I went ahead and typed this up beforehand just to save time. We'll say main menu, and the user can either, let's say, reset game, show high scores, or they can quit. And then we'll prompt them to enter a value. So let's go ahead and do scanner.next line. And then since we are saving it as an int, let's go ahead and convert it to an integer by using integer.parseInt, surrounding it with parentheses. So once we have the value, let's just go ahead and print it out. Let's say you entered, and then the user value. So basically they're going to do this while the user value does not equal 3, because once they enter a 3, that's going to quit and it's going to exit the program. And then at the end of the while loop, let's print something out. Let's just say goodbye. All right, so let's run this and see if everything is working properly. So here we see main menu, reset game, show high scores, or quit. So enter a value. Let's enter a 2. And you know what? I want this to be on the same line. So I'm going to change this to just print. I'm going to rerun it. There we go. Main menu, reset, show high scores, or quit. So let's do a 2. And here it says you entered a 2, and then it prints out the menu again. Let's do a 1. And to reset game, technically, this really makes sense, because if we reset the game, it would probably do something else, but for demonstration purposes, it's fine. And then finally, we'll do a 3. It'll say you entered 3, and then goodbye, and then the program finishes. So let's just do a recap here. We first create our scanner to get the user input. Then we declare the user value as an integer. Then we run the body of our do while loop, which just displays the menu, and it asks the user for a value. The user enters something, we get that value, we convert it to an integer. Then we basically echo that back out to the user saying you entered whatever their value is. And this continues until the user enters a 3. Once the user enters a 3, it breaks out of the loop and it prints out goodbye, and the program ends. So this is a pretty basic example of a do while loop. I'll be completely honest, I probably use the do while loop like 1% of the time. Java has 3 loops. For loops and while loops are probably 99% of the time that's what you're going to be using, but it is good to know what a do while loop looks like just in case you ever encounter it. But most of the time you're going to use for loop or while loop. All right, let's talk about the break and the continue keywords. They're both related to loops, so let's start with break. Now, whenever we're inside of a loop and we reach a break statement, it immediately breaks out of the loop and continues to the next statement, hence the name break. So let's create a simple while loop. Let's create a variable called count, and we'll say while count is less than 10, then we'll just simply print out count. And then don't forget to increment our count. And then at the end of our while loop, I'm going to just type out loop ended, just so we know that we've reached the end of the loop. All right, so if we look at the output, we have the expected output of 0 all the way down to 9, and then we get to loop ended. Now, say for some reason, whenever we reach the value 5, we want to end the loop. We don't want to continue. So we could just do if count equals 5, we're going to break. And then let me do a print statement up here just to show that we've actually entered this if statement. So breaking out of loop. All right, if we go ahead and run that, we see that we get 0, 1, 2, 3, 4. And then it goes into this if statement. It says breaking out of loop, and it gets to this line right here, and it says loop ended. All right, so let's just do a quick run through here. So our count is 0. So then it goes while count is less than 0. So then it goes in here. If count equals 5, well, count is 0, so it doesn't go into this if statement. It prints out the value of count, which is 0, and then it increments count. And it does that all the way up until it gets to 4. And then it increments count to 5. And then while 5 is less than 10, yes it is, if count equals 5, which this time it is, so it goes into this if statement, or the body of this if statement. So it prints out breaking out of loop. It gets to this statement right here. So then it breaks out of this while loop, goes to the next line, prints out loop ended, and then the program finishes. So that's an example of how to use break. So let's talk about continue. So continue basically stops the current iteration and goes back into the top of the while loop. So let's say instead of a break here, we had a continue. Whenever it would get to this continue, it wouldn't execute the rest of this current iteration. It would automatically go back up to the top of the while loop and start to check the condition. So in this example, it doesn't really do much. So let's create another loop that prints out the even numbers from 0 to 100. So this time, let's use a for loop. So we have int equals 0, int I equals 0, and then we'll go until I is less than or equal to 100, and then we'll increment every time. Now, of course, if we really wanted to do this, we could just increment I by 2, and that would work, but we want to demonstrate how continue works. We said we want to print out the even number. So if I is ever odd, or if I mod 1 equals 0, then we're just going to continue. Otherwise, we're going to print out I. And this should actually be mod 2. So we're dividing by 2, and if the remainder is 1, then we don't want to do anything. We want to continue and go back up to the top of the for loop. Otherwise, we're going to print out I. Let's go ahead and run that. And we see we get all the way at 0, 2, 4, 6, 8, all the way down to 100. So again, we're going into this for loop. I initially is 0. Is 0 mod 2 equal to 1? No, it doesn't. So print out I, which is 0. Then on the next iteration, I is now 1. Is 1 mod 2 equal to 1? Yes, it is. So continue. Don't go into this print statement. Just go back up to the for loop. Now I is 2. Is 2 mod 2 equal to 1? No, it's not. So print out 2, as we see here. And it does that all the way till it gets to 100. And then the for loop ends. It breaks out, the program ends, and everything looks good. So those are the break and continue keywords. And they always have to fall within a loop. So if we try to do something like a break here, it's going to give us an error and say break outside of switch or loop. So you could also use it in a switch as well. Again, also with continue, if we try to use continue outside of a loop, it says continue outside of loop. In this section, we're going to talk about methods. Now, methods are one of the most important topics in Java, and what a method is a block of code that when called performs a specific action. So as we see here, we have a menu, and if we run it, we get main menu, reset game, new game, quit game. Now I'm going to move this into its own method. And what that's going to look like is, so right after our main code block right here, but still inside of our main class, I'm going to type public static void. And now we need to give our method a name. I'm going to call it print menu. And then we need an open and close parentheses. For now, we're just going to keep it empty. And we need an open and close curly brace. And then right here, this is our method body. So what I'm going to do is I'm going to cut this and I'm going to paste it in here. So now if we run our program, if you look, nothing gets printed out. And that's because what happens is when Java runs, it looks at the main method and basically runs all the code inside these curly braces. Well, right now there's nothing in it. So in order to use this print menu method, we need to call it. So how we do that is we simply just type print menu and then open and close parentheses. And since this is a statement, we need a semicolon at the end. Now, if we run the program, we see we get this main menu. And just to better demonstrate what's going on, I'm going to write a couple of print statements. So if we go ahead and now run this, we see, okay, the program runs. It runs this first line here, calling method, and that's what gets printed out here. Then it calls print menu. So what happens here is it suspends the program and it goes into the print menu method. So then it prints out these 4 lines, main menu, reset game, new game. And then once the method is done, then it resumes execution after the method is called. So then it goes to this line here, method finished, which we see down here, and then the program ends. So what's the point of using this method here? Well, a couple things. One, it keeps our main method clean, which is typically good practice. We don't have to have all these print statements within our main method. Secondly, if we ever want to print the menu again, all we need to do is simply call our method. So if we run this, we see down here that print menu gets called 3 times. If we didn't have this method, we would have to type out these 4 lines 3 times. So we'd get 12 lines of code instead of 3. So we have this reusability here, which also helps with the readability of our program. Now we have 2 ways to return from a method. The first way, which we just saw, was the method simply runs all its code, it gets to the end of the method, and then it returns. But we can also use the keyword return if we ever want to exit early. So say we have another method here. We'll say public static void, and we'll just call it print stuff. So let's do a for loop. And let's create a variable I, and we're just going to print it out 10 times. And then in order to call it, we need to call it in our main method. So print stuff. So if we run that, we see that we just get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But say we want to exit early. So we could do if I equals, let's say, 5, then we're going to return. Now if we run that, we see it gets to 0, 1, 2, 3, 4, and then when I equals 5, it goes into this block of code here, and it returns, and the function automatically exits and goes back to the next line after print stuff, which in this case is nothing. So the program ends. All right, so now let's talk about parameters and arguments in methods. So let me go ahead and delete all this and delete this right here. So say we want a method that gives us the area of a rectangle. So what we could do here is we can create a method. We'll do public static void, and we'll say print area. Well, in order to get the area, we need to have a height and a width. So this is where parameters come into play. So in between the parentheses here, this is where when a function gets called, we can pass values into it. So we could do something like int height and int width. So these are two parameters. So whenever you have a parameter, you need to have the type, which in this case is an int, and the name. So what we could do here is we could create int area equals height times width. And then we can simply just print this out. Say the area is area. So now when we call this here, we would type print area to call the method, but now we need to pass it in a height and a width. So let's just say we want a height of 3 and a width of 4. So if we run this, we see that it says the area is 12. So whenever you pass in values into a method, these are called arguments. When they're defined in the method, they're called parameters. So just a little bit of terminology there. Now a couple things, the order matters here. So if in our method, the first parameter is a height and the second parameter is width, when we pass in the arguments, the first argument refers to the height and the second argument refers to the width. Also, the argument type has to match the parameter type. So since 3 is an int and height is an int, we're fine. But if we ever change this to like a double, we're going to get an error here. It's going to say required type int provided double. So we'd either have to change this back to an integer, or down here we could change the type to a double. And then we'd also have to change a few things down here as well. I'm just going to change this back to an int. In this section, we're going to go over returning values from methods. Now here in our print area method, it gets the area and then it just prints it out to the console. But what we can do here is get the area and basically return it, so then we can set a variable to whatever the value is. So what we could do here is let's change the name first to get area, and we need to change a few things here. First, instead of printing it out, we can just do return area. Now we see we get this red squiggly line and it says cannot return a value from a method with a void result type. So this is where this void keyword comes into play. When we have a void, this means that we're not returning anything from it. However, here we're returning area, which is an integer. So in Java, you have to specify the type of what you're returning. So in here, instead of void, we'd change this to int. And now we see this error is gone. And now what we can do up here is we can create a variable called area, and we can set area equal to this method here. So now if we print area out, we see that we get 12. So what's happening here is we first create our variable called area, then we call the getArea method with arguments 3 and 4. So what it does is it goes in here and it says, okay, this int area equals height times width, which is 12. So now return 12. So basically 12 gets returned to here and sets it to this variable area. And then we simply print out the value of area. Now, one thing that could be confusing here is this area and this area are totally different variables. So what we could even do here is instead of creating a variable, we see here local variable area is redundant. We can actually just delete this and delete all of this and simply return height times width. So in the previous case, when we had a void here, we were simply just printing out to the console. Now that we have an int, we're returning a value from this method. And a method can return any type. So we could have had something like a string in here. We could have had a double, just pretty much whatever you wanted of it, but you just have to make sure that it is actually returning the type that you specify up here. Before we move on, we need to talk about the lifetime of variables and scope. And no, I'm not talking about the mouthwash. So far, pretty much every variable that we've created has been declared at the start of main, right? So we've had like int x or string y, But in Java, you can declare variables within any code block. So as we explained in, one of the first videos, a block or a code block begins at the beginning of a curly brace and ends at its corresponding closing curly brace. And this block right here defines the scope. So every time you start a new block, you're also creating a new scope. And a scope determines what variables or objects, I know we haven't talked about objects yet, but what variables are visible to the other parts of your program. And it also determines the lifetime of those variables. So say we do something like if, and I'm going to change this to an int. So we'll say if x equals y, and let me give a value to x, so 10, and y equals 11. So this right here, this opening and curly brace is a scope. And it's also within the scope of our main method. This scope right here is nested within this scope right here. So what we could also do is we can create a new variable within this scope. So when we create a variable within a scope, we say that it's local to this scope. It's a local variable. So when this happens, the outer scope encloses the inner scope. So the variables declared within the outer scope, these two variables, are visible within this scope. So we could do something like x equals 15, y equals 20. And this is totally fine. However, the reverse is not true. So this z right here, since it's declared and initialized within this scope, it's not seen within this outer scope. So if we try to do something like update the value of z to, let's say, 7, it's going to give us an error here, and it says, cannot resolve symbol z. So what's happening here is it creates the variable x, creates the variable y, and it goes into this if statement, and then it creates this variable z. It sets the value to 12. It updates x and y, and this is fine because this inner scope can see the variables that are in the outer scope. But then once this if statement ends, anything that was created within this scope basically dies or goes out of scope. And that determines the lifetime of a variable. The lifetime is when it's declared, and the lifetime ends when it's called going out of scope, whenever the scope that it was created in ends. So when it goes out of scope, the variable is destroyed. It is also worth mentioning that setting the variable's values in x and y, it does keep its value even after this scope ends. So I'm going to go ahead and comment this out. And let's go ahead and print out x and print out y. If we run that, it's actually not going to update it because this is false. So let me change x and y, set these equal, so we'll go into this if block. All right, we see that x gets updated to 15, y gets updated to 20. Even though this scope ends, x and y keep the value that was updated within the if block. Another thing to mention is in here, we can't create a variable with the same name of a variable that's within this scope or an outer scope. So we can't do int x. It's going to say variable x is already defined in the scope. And regardless of whether we change the name or not, it doesn't matter. It has to have a new name. All right, let's do one more example here. Let's create a for loop that just counts up to 10. So count is less than or equal to 10, I plus plus, not I, count. And then let's just print out the value of count. Just a simple for loop. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's do something here. Let's create a variable that's local to the body of the for loop. So this scope right here. Let's create a variable called x. And let's update x equal to 100. Let's initialize it initially to 1. And let's print that out. So we'll print out x here, and then we'll print out x here. And I'm going to change this to 5 just to keep it simple. So if we run this, we see we get 1, 100, 1, 100, 1, 100, 1, 100, 1, 100. So basically what's happening here is we're creating this variable x, we're setting the value to 1, we're printing out 1. Then we're updating the value of x to 100, and then we're printing out x. So we get this 100 here. Then when this for loop iteration ends, all the local variables, which we just have one, which is x, all these local variables get destroyed. So once we start the new iteration, we create a new variable called x. So this is a completely different variable than the one that we had in the previous iteration. So again, we print out x, it's a 1. We update it to 100, we print out 100. The iteration ends, x gets destroyed, and it starts the loop all over again. So just to recap, the lifetime of a variable starts when the variable gets declared, and the variable is destroyed when it goes outside of the scope that it was created in. And a scope is a code block that starts with a opening curly brace and ends with its corresponding curly brace. If we take a look here, every Java program has this public class main. So you've actually been writing all your code inside of a class. So you might be asking, what is a class? Well, a class serves as a blueprint to create objects, and objects are an instance of a class. If that's confusing, I don't blame you. I think the best way to understand this is by doing an example and explaining it as I go. So let's take a look at some code. All right, so here we have the general form of a class. You're gonna have the keyword class saying, hey, this is going to be a class that I want to define. And then you're going to have to give your class a name. And then the body of the class would live in between these two curly braces. Now there are two things a class can have, either variables or methods. So here we define two variables, which when they're in a class, they're going to be called instance variables. Now these can be really any variable type, and you can have as many as you want. So the other thing you can have are methods. So here we have an example of two methods, and you can have 0 or more in a class. So they can be different return types, they can have 0 or more parameters, etc. One thing to mention is that even though it's not enforced or anything by the language, a class should be defined as a single entity. For example, you could have a class called person, and it could have something like a name or an age, but it wouldn't make sense to put something like the weather or something in that class. That's a good way to write messy code, and you don't want to do that. So if we go back to our method here, let's go ahead and create a actual class. So I'm using IntelliJ. I'm going to go to File, New, Java Class, and what do we want to do here? Let's do something a little fun here. Let's make a Pokemon class. All right, so here we see public class Pokemon, and for this tutorial, you don't need to worry about what this public is doing, but this is an empty Pokemon class. So let's write our instance variables here. Let's give our Pokemon a name. And let's give it a level. And what kind of method should we give this? Let's write a method that doesn't return anything called attack. And in here, we're just gonna print out, we'll say the name, and then we'll just say attack. Now that we have this class defined, this class will be a blueprint for creating objects. So how do we declare and initialize objects? Well, first you want to just type the class name, then you want to give your object a name, and then you want to actually create the object itself, which uses the new keyword and the class name. So in our case, how would that look? So we type Pokemon, which is the class name, and we have to give our object a name. We'll just call it P1 equals new Pokemon. So for now, don't worry about what this parentheses mean. We're going to get into that. So assignment in Java works from right to left. So what's happening here is first, we're creating this object here. So Java is going into the memory and it's allocating space to create this object. Then it's setting it equal to this Pokemon variable. So now if we ever want to access anything in our Pokemon object, we use this P1. So how do we do that? Let's take a look. So now if we want to set the name and the level for our object, we would do something like P1, and then we would use a period here, which is called the dot operator. So we do dot name, and then we give our Pokemon a name. I feel like for the first one, we got to go with Pikachu, and then we got to give it a level. So it would be P1 dot level equals, let's just say level 10. Let's go ahead and print that out. All right, so let's go ahead and run that, and we see that it says Pikachu 10, which is what we expected. All right, so now we have one object, but now you can create as many objects as you want. So let's go ahead and create another one. Let's call this one P2. So let's give this one a name and a level. All right, so we have another one. We named it EV and we gave it a level of 20. And then let's go ahead and call the attack method. So now if we run that, we see that it says EV attack. And here we should actually go and add a space here. So if we run that, we see that it's now properly formatted and it says EV attack. One important thing to note is that these objects have their own set of variables. So P1 gets its own name and its own level. P2 gets its own name and its own level. If we change a variable for P1, it does not affect anything in P2. That's really one of the fundamental principles of objects. It's that variables and methods are encapsulated within the object, and changing the variable in one object does not affect the variables in another object. So that's really the basic idea of classes and objects. The class is a blueprint for some kind of entity, in this case, Pokemon. And then we use that class to create objects of it, which have variables and methods defined from that class. All right, the next thing we're going to go over are constructors. Sometimes when you create an object, you want some sort of code to happen. Maybe you want some variables to get set initially. That's where constructors come into play. These are special methods that get invoked as soon as an object is created. So if we go back to our Pokemon class, how that's going to look is it's going to be its own method. It's not going to have any return type, and it's always going to be the same name as the class. So in this case, it would just be Pokemon. We have our parentheses, and then we have the body here. So say initially when we want a Pokemon to get created, we automatically want all of them to be set to level 1. So what we would do is we would just say level equals 1. So now when an object Pokemon is created, this function gets called and the level automatically gets set to 1. Let's take a look at an example. So let's go ahead and get rid of pretty much all of this here. And let's go ahead and print out the level. So we see that we're going to print out p1.level. Now, if we didn't have any constructor, this integer always gets set to 0. But since we have that constructor where we set it to 1, we run the code and we see that a 1 gets printed. Now, say we want the user to give us a name and a level. How would we do that? Well, what we could do is we could add another constructor that has parameters. So let's go ahead and do that. And then in the body of the method, we'll just set our actual variables in the class equal to what gets passed in as the parameters. All right, so let's go back to our main function, our main method. Now, when I say method and function, I'm using these interchangeably. In Java, they're called methods. In other languages, they might be called functions, but I'm referring to methods. All right, now let's go ahead and create an object passing in arguments for our constructor. So how that would look like is we would just create an object like we normally would. Now, when we want to pass in variables to our constructor, this is when, remember when I said we're going to talk about these parentheses later on? Well, this is that time. So the arguments would actually get passed into these parentheses, and this is what represents the constructor. So let's go ahead and pass in a name and a level. So now this first argument refers back to this string pname, and this level 25 refers to this int pLevel. And then our name and our level, our instance variables, get set to these arguments. And yeah, let's go ahead and print this out. All right, so initially we're just printing out p1.level, and then we're going to call p1.attack. Let's go ahead and run that. So we see that they're printed on the same line. Let's go ahead and give us a new line here. So we see p1.level prints out 25, and then p1.attack calls EV attack. So we see that the EV and the 25 get set because we pass these in to the constructor. Say for some reason in our constructor, we wanted to call this string name and string level. And then in here, we want to set this name equal to name and level equal to level. Well, you see how this gets kind of weird here because name is the same as our instance variable name and same with level. So which one does it use in here? Well, what it does is it always uses the most local variable. So in this case, it would use the arguments that get passed in. So what's happening is name is just getting set back to name, level is getting set to level. None of these instance variables are being used at all. So how do we get around this? Well, Java has the this keyword. So what we would do is we would just do this dot name and this dot level. So whenever you use the this keyword, it's saying use the variables that are actually defined in this class. So this is just an explicit way of telling Java that we want to use these variables. And you could even use this for methods as well. So if we wanted for some reason, we could actually call this dot attack in the constructor. All right, that's going to wrap up this tutorial. Just to recap, we talked about creating classes, creating an object class of that type. We went over constructors to initialize instance variables, as well as passing parameters to constructors. Finally, we wrapped it up by talking about the this keyword. Hey everyone, Sam here. I really hope you enjoyed this tutorial. I just wanted to let you know that this tutorial you've been watching is the first part of my Java for Beginners course. And the full course goes way beyond this tutorial and introduces important concepts that are essential for becoming a competent Java developer. We go more in depth with methods and classes. We talk about inheritance, interfaces, and much more. I'll leave a link below in case you wanted to check it out. Thank you so much for watching, and I'll see you in the next one.